and productive unnecessary discussions. If you don't, then I'll go on a rampage, crack 50 dad jokes, waste 1 hour, and then you guys will start scrambling to figure out what did we learn in 1 hour. Okay? Okay. Arav, that's not funny at all, beta. Your sense of humor is not helping here much. So let's stick to the class. No, you have to be mindful of everybody's time. Okay, let's not waste everybody's time.
That's very cool.
I mean, I'm almost 50 now. I have not figured out how to make somebody understand some basic stuff. Okay, let's look at what we are wanting to learn today. So today we will start with geometry and deal with angles between intersecting lines and and also follow some concepts on similarity of triangles. Hands down, you have not impressed me enough to let you have that extra privilege. No, I've not even talked about anything. Alright, so we are starting with geometry. So Advik, you also have to control. Fire burns. Don't add fuel to it. Okay? Yeah. Alright. So Sanvita. So everybody is able to hear me okay and see the board okay, right? Now let me start with some very basic stupid concepts and then we'll see how you guys are able to relate to it. Yeah. So I have two situations and try keeping it as simple as possible, otherwise I will struggle due to my lack of intelligence. Arya knows what I'm lacking right now. I'm lacking intelligence right now, big time. So we have two situations, okay? This is situation 1 and this is situation 2. How do you describe what is the situation 1 and what is situation 2? And Arab is not the one who's going to answer it. Okay. Neither Advik. Everybody has to be given a chance to participate, and there's some kids who need that gentle push to participate. That's what I'm doing right now. Hello. Yeah, okay.
The first one is intersecting and the second one is just parallel.
Okay. Let's see what Sanvita says.
The first one is like perpendicular and then the second one is parallel.
First one is perpendicular. I knew my drawing skills are horrible, but did I do that bad a job?
Oh, never mind. It's intersecting.
Okay. It's intersecting.
The second
Yes.
one will eventually
Yeah.
intersect.
Okay. Anybody else? Yes, Laksh. Go ahead.
Number uno is intersecting and number two is parallel.
No, you have to be a little louder. I could not hear you because of some of your friends are creating extra sound here in the class. That sound effect is disturbing me.
Number one is intersecting and number two is parallel.
Okay. Nihan, you agree with whatever you heard from your friends?
Yeah.
Suhina, Sami, everybody agrees? I mean, there's nothing
Yes, sir.
addition to that, right? Sorya, Milana, everybody's okay, right? Now, so this is intersecting line where the lines are meeting somewhere. This is where the lines are not meeting. We are calling them parallel. Okay? So this is a very common pose for taking pictures during marriage, right? I mean, you would have seen the groom and bride, they take pictures like this, but let's not worry about that. Let's come here. Guys, you guys have left that phase of, no, don't do that. This is something I worship. I don't want you guys to touch it with your feet.
They worship that.
Okay, bye-bye. So, books, pencils, pens. These are things that we worship. Don't touch it with your feet. Don't be disrespectful to it. Okay? Alright. I'm not asking you to worship like the way I do, but don't disrespect. Okay? Alright. So, this is when these two lines are meeting, they are called intersecting lines. When the lines don't meet, and when I'm saying lines, if you guys recall your childhood days, I'm talking about things which doesn't have any end point. You can extend it as far as you can think of. If I had a much bigger board, this would have been much bigger in size. So here I'm talking about lines. I'm not talking about line segments. I talk about line segments where I don't have arrows. I have starting and ending point fixed. Here I don't have ending and starting point fixed. Meaning they will not meet regardless of how far I extend them in this direction or this direction. Is that okay so far? And there's another thing that you would want to remember or keep in mind is when you have a pair of Arab, why that extra sound is needed? No, Arab, this is not fair. This is being unfair to the quorum of the class. Advik, you are not doing anything interesting either. If I'm scolding him or reminding him, if I'm requesting him, begging him now, that's the situation it has gone to follow certain rules, and you're adding more to it. Not needed, please. So when we're talking about the parallel lines, another thing that you have to keep in mind is, first is they're not going to meet, or the interpretation from that would be the perpendicular distance between the two lines will remain the same. If you are measuring the distance here or you are measuring the distance after 2 miles, the distance between the two lines will remain the same. Okay, that's how they are parallel. That's how there is no chance of them meeting. But I was not here for teaching you guys that the parallel lines don't meet. That is something that you guys already knew. I am adding more to it, more properties of it, and that is what I would want you guys to be aware of, and we will deal with angles today. So here when you are looking at the intersecting lines, what are these angles called?
Like inner angles.
Stop it there. Going down direction.
Interior angles.
Stop it there. Anybody, what are these angles called? Yes, Milana. Milana, you're not Milana. I'm sorry?
Acute.
Acute based on its size, but I'm saying what are these two angles called? So there's some relationship between these two angles. Yes, Sammy. Let everybody get a chance.
Connecting angles or parallel angles?
Corresponding angles.
Yeah.
Congruent angles.
That's not
Dikshita. What are these angles called?
Perpendicular?
Opposite angles, simple. They're opposite to each other. When the two lines are meeting each other, this angle and this angle are called opposite angles. This angle and this angle are called opposite angles, and they'll be the same. That's what I was trying to figure out. Go by some basic stuff. Opposite angles, they are opposite to each other. When two lines are intersecting, these are opposite angles, and they'll always be the same. Any two lines in the world. This $1 million line and this 1 cent line, even if they meet, the opposite angles will be the same. Okay? This angle and this angle will be the same. Is that okay so far? Shannon, Serene, okay, beta? Yes, Ami, okay?
Yes, sir.
Okay. Suhina, okay?
Yes, sir.
Okay. Now, let's add a little more to it. Now, these are two parallel lines. Let's say I call them A and B. Now, we are mixing it. I'm using a third line C, which is intersecting both the lines. So far, life looks okay. We have a pair of parallel lines, and we use a third line, which is called intersecting line, which is apparently intersecting both of them. And then we are seeing some interesting angles. Here in this case we had 4 angles, and we say okay, opposite angles are same. That's one interpretation. Now here we are seeing 4 angles here, 4 angles here. We are trying to derive relationship among them. Now if I'm looking at this is angle 1 and this is angle 2. What are these called? Okay.
Congruent angles.
Sanvita,
Corresponding angles.
Vasundhara,
Corresponding angles.
Nihan.
Corresponding angles.
Okay. Arav?
Oh, I was gonna say corresponding angles.
Listen to the question first before you raise your hand. Otherwise, it looks like even if the dandiya is got over 1 month ago, you're still doing dandiya here in the class, okay? So don't do that. Now, these two are corresponding angles. How about this guy and this guy? Let's say this is 3 and this is 4. How about 3 and 4?
Corresponding angles.
Nihan?
Corresponding angles.
Rahi? Corresponding angle. So basically, when you have a pair of parallel lines and the third line intersects both of them, these angles are corresponding angles. These two, this, let's say this is 5 and this is 6. 5 and 6 are corresponding angles. 7 and 8 are also corresponding angles. So, why they are called corresponding angles? Look at the behavior of these angles. Let's say we talk about 1 and 2 only. Let's not make it complicated for now. We are talking about 1 and 2 only. 1 and 2 are called corresponding angles because they correspond to certain behaviors. Both the angles are above the parallel lines and on the same side of the intersecting line. Both are above. See, this is the line, this is above this. This is the line, this is above this. Both the angles are above the parallel lines and on the same side of the intersecting angles. Does it make sense? Now, this angle, let's say this is 3 and this is 4. We are calling these two also corresponding angles because both are again above the parallel line and the same side of the intersecting line as well. So they have something in common. Okay? This one and this one we are calling corresponding angle because both are below the parallel lines. This is below this line and this is below this line and the same side of the intersecting line. Yep. And one thing you would see is if I bring my magic box. If I bring this magic box, everybody knows, I mean not box, magic tool. Everybody knows what is this called? It's not bow and arrow. I'm not going to start shooting arrows out of it.
I know what it is, like, but I don't know the name.
What is it?
Is it a protractor?
Yeah. Lach, what is this called?
Protractor.
Protractor. Yeah. So this is used for measuring the angles. If you use this one and if you draw a better line than me, right? Don't rely on my drawing skills. When you have a pair of parallel lines and an intersecting line crosses both of them or intersects both of them, you will see that the corresponding angles are of same value. Okay? This angle and this angle will be the same. So that is the first thing that you would need to keep in mind. That is, if there is a pair of parallel lines and a third line intersects both of them, the corresponding angles will be the same. So this angle will be the same, this angle will be the same, this angle will be the same, this angle will be the same. So far it's okay? Now, corresponding angles are same, that part is okay. There are some more flavors of it. Let's look at some more angles. Is anybody getting bored right now? Except me? Anybody getting bored right now? So this is a pair of parallel lines, this is the third. So corresponding angles are same, that is understood. How about this guy and this guy? What are these angles called? There are other kids also in the class. Let everybody try. If I don't hear anything, I'll come back to you guys. Yes, Vasundhara?
I think they're called alternate interior angles.
Okay. How about Advik? What are these called?
Interior angles.
Sanvita?
Alternate interior angles.
Sani and Celine?
Alternate interior angles.
Okay, Dikshita. So basically you guys are all right. These are called alternate interior angles. Now if I ask, what is the relationship here? Like for the corresponding angles we said that they are the same. Are these also same? No? What do you think?
Yes.
Okay. Anybody? Or what is the relationship between these angles? Like corresponding angles are same. I'm asking you guys to tell me whether the alternate interior angles are same or not. So here, interior, both are interior, meaning between these two lines, and alternate, meaning on the alternate side. So this is this side, this is this side. Similarly, this one. Let's say this is 1, this is 2, this is 3, this is 4. So 1 and 2 are alternate interior angles, 3 and 4 are alternate interior angles. Now I'm asking you guys, what is the relationship between them? Are they same? Is 1 and 2 same? Yes, Arihan.
1 and 2 are the same. 3 and 4 are the same.
Okay. Anybody in the class who doesn't believe what Arihan is saying? I did not say so. Milana, what's going on in your mind right now? Are you trying to process why Arihan said so? And how do you believe him?
Yeah.
Yeah. How about Ariyahi? What are you thinking right now? You don't think they are same? Arav, you said they are not same.
Which one?
Alternate interior angles are not same. So 1 and 2 are not same. That's what you said, right? Advik, you said they are same. So I am getting contradictory thoughts here. Some of you said that they are same. Some of you are saying, you'll get it after the class. Some of you said that they are not same. And I am confused right now. Whom to believe, whom not to believe. Let's decode this together. And some of you who are saying that they are same would think that this is a waste of time. Apparently it's not. Okay. So Hiranya and Maida is not in the class anyways today. Hiranya and I'm just checking some of the kids who don't speak much. And Gayatri and Saurya. Just here the debate is about whether the alternate interior angles are same or not. Yeah? And what is your opinions? Gayatri, Hiranya and Saurya. What do you think?
So can you repeat what you asked? Your voice was breaking for me.
Okay, so this is a pair of parallel lines. This is the third line intersecting both of them. And these angles are called alternate interior angles. The question is, are these same or not? Some of you are saying yes, they are same. Some of you are saying no, they are not same.
Is that my water bottle? Like this one over
Yeah.
here? Did I leave it yesterday?
Yeah. Okay.
You're talking about the water bottle.
Yeah, could be yours. Yep.
Oh, mine? Okay.
Okay. So here we are trying to figure out whether they are same or not. Yes, Milana is saying something. Yes, Peter, go ahead.
I think they're not same.
You also think they are not same? Now I'm in a dilemma right now, whom to say yes and whom to say no. Okay, let's see what Saurya says. Yes, Saurya, what do you think?
I think they're not the same.
Okay, Arihan?
Can I explain my thought process?
That job you can leave for the teacher, but yeah, I want to hear everybody's opinion first. Gayatri, what do you think?
I think they're the same.
Yeah, you think they are same? Okay, Gayatri,
I think they're the same.
yeah, same. You think they are same? Sami, Sanvita.
I think they're not.
Okay, now so I heard most of you. Some are saying same, some are saying not same. Sami and Suleen, what do you think?
Same.
They're same. So here, look at it. I don't really know how to solve some of the problems. I mean, I can solve mathematical problems. This is not mathematical in nature. This is psychological in nature.
Why that? Why like that?
Okay, yeah. No, you know why they're laughing.
I'm not laughing.
You are the one who is seeding the problem right now.
Just say Coach Boy.
Okay, stop that right now.
Okay.
Okay, here we are looking at these two angles being the alternate interior angles, and we are trying to figure out whether they are same or not. Forget about this for now. Now let's say this is 1 and this was 2. I'm saying forget about 1. I'm thinking about other angle 3. 3 and 2 are same. That's what we agreed a little while ago. Correct? 3 and 2 are same because they are corresponding angles. And I showed you my weapon, which can be used for proving it. Yeah. Now Look at this angle and this angle. Forget about the third line right now. These two angles are what? Opposite angles. This is one line, this is another line, intersecting each other here. These two are opposite angles. So this angle and this angle has to be the same. So look at what we are saying. 2 is equal to 3. 3 is equal to 1. Can we not say 1 is equal to 2? 1 is equal to 3, 3 is equal to 2. So is not 1 and 2 equal? Are these two equal? No, again, keep it simple, keep it light. Your corresponding angles are same, that we already know. And this angle and this angle are opposite angles. When you don't visualize this line, okay? The third line, you don't. Just look at these two lines. Opposite angles will be the same always. Yeah, Milana?
They are the same.
They are the same. So opposite angles are same. These two are same. 3 and 1 are same. 2 and 3 are same because they are corresponding angles. So 1 and 2 have to be same. There is no choice. So this is the second property of parallel lines and intersecting lines. One is the corresponding angles will be the same and the opposite internal angles or alternate internal angles will be the same as well. Yep. This was the theory that I wanted you guys to be aware of. Now let me give you guys one last magical formula and then we will start jumping onto some problem that we want to solve together. I see some kids are missing, but okay, they'll have to watch the video. Now I'm saying all the shapes that you see here, triangle, rectangle, pentagon, quadrilateral, hexagon, whatever. I'm saying if you have to find out sum of all the angles of any shape, how do you derive it? Let's say if I'm saying triangle, sum of all the angles is how much? You will say, okay, 180 degree. If I'm looking at a rectangle or quadrilateral, what is the sum of all the angles? You will say 360 degree. How about this guy and this guy? Yeah, Laksh.
If you want to know the sum of all the interior angles, you'd have to minus the sides by 2, and with that number, minus the sides of how many sides the shape has, and then you multiply that number by 180. Because the triangle has 3 sides. 3 minus 2.
So you know it, Laksh, but you are missing one important thing here. You're saying you said say one more time.
So you have
Let's say they are yeah.
subtract the sides the shape has by 2.
2 minus number of sides.
No. Number of sides minus 2.
Okay. And then
with that number, you multiply that by 180.
okay. Yeah. Then this is right. So yes, Arihan, you're saying something.
Wait, I don't know if this one works, but number of sides times 90 and then minus 60.
May not work. Number of sides minus 90, then times 60.
No. Number of sides times 90.
Number of sides minus 90,
Times.
then
Number of sides times 90 minus 60.
no, it will not. It will not. Because let's say if you talk about triangle, here you will put a 3, it becomes 90 into 3, that is 270 minus 60. This is not what it is. Yeah.
Oh, yeah.
So here n minus 2 into 180 or 2n minus 4 into 90, whatever you can remember, okay? This is a magical formula that tells you sum of all the angles of any shape.
Wait, which one?
N minus 2 into 180 or 2n minus 4 into 90, whichever you remember, okay?
Couldn't we just remember it by like adding 180
No, that will not work.
So 2 and minus.
Yeah.
N represents the number of sides.
N represents the number of sides.
Or angles.
No, huh? It doesn't matter. I mean, let's not complicate
What's
it.
y?
Huh?
What's y?
Why?
Why?
Is that
In this. No,
Your name was put RF. Why?
No, I'm like in this. Like,
So we'll see. This is a okay. So here,
It's a 4.
2 and minus. Oh no, does it look like y? I know my writing is horrible, but is it that horrible?
Oh.
That 4, my 4 and y are like this.
My bad.
No, your foot looks like a U. I'm not gonna lie.
Anyways, let's not spend energy on that. So here, this becomes a formula that you would want to keep in mind. That will help you find out some of interior angles for any polygon. Let's say if I'm talking about triangle, 2 and minus 4, or let's say n minus 2. Let me remember Lux's formula. N is the number of sides, so 3 minus 2 times 180. 3 minus 2 is 1 into 180. Perfect. Let's say n is 4. So 4 minus 2 into 180. 4 minus 2 is 2 into 180, 360. Now it gets more interesting to find out some of all the angles of a hexagon, let's say. 6 sides. Nobody would remember it, right? So put n equal to 6. 6 minus 2 is 4. 4 times 180, 720. That's the sum of all the angles of a hexagon. You're talking about some. What is that?
I'm doing it.
I promise. I'm actually writing my notes.
It's okay, calm down. That is unnecessary waste of time. Why are we doing that? Calm down, okay? Whenever you are getting tempted to get distracted, take a deep breath. Take a deep breath. Take a deep breath. It's okay. So if, guys, hold it. In the exam or in any situation, if you have been asked, what is the sum of all the interior angles of a polygon which has 15 sides? You don't have to draw 15 sides. Put that in the same formula, n minus 2 into 180, and that will be it. Okay? N is 15. Find it out.
So,
But, no if, no but. Let's move on. Yeah.
4,600.
It's okay, it's okay. It's okay. I was just giving an example.
It's one. The answer is 1,620.
And you guys will hate me for this sentence. I don't care about the answer. I was just telling you guys that this formula is the magical formula that you can apply anywhere and everywhere. Whenever you forget, right? Let's say you are in an exam-like situation where you are stressed out a little bit, and then you are trying to find out sum of all the angles. You are seeing a quadrilateral, but you forgot it's 360. Apply that formula. Whichever you remember, you can apply it. Now, let's look at some actual problems that you guys would need to deal with. Otherwise, we will keep on talking about things that are not needed.
you're like that. I like you.
RF,
My bad.
my bad, your bad, my neighbor's bad doesn't help. Just stop it there. In last 15 minutes, you have said my bad 20 times. What is the takeaway from that? Are you learning from it, or that has become a defense mechanism that okay, I'll keep on committing mistake and keep saying my bad?
That's what he does in school.
Here, you watch here. Otherwise, you'll also have to say my bad 20 times. No, I'm saying. So, see again, I'm trying to make him understand something. If everybody pounces on him, what will happen? Nothing. Okay. Now look at the first question, guys. This is given as 34 degrees. You have been asked to find out the value of x. Yeah.
Wouldn't it still be 34?
So tell me with confidence.
34 degrees.
That's it.
34.
My bad.
See, within 30 seconds. One more, my bad. Yes, Anvita.
And this is my problem.
Yeah. So, since we deliberated this one, okay, so I'm not going to give chance to everybody to say 34 degrees. Anybody who got anything different from 34 degrees, raise your hand.
What?
Anybody who got more different from 34 degrees, raise your hand. This is nothing but the basic understanding of corresponding angle. These two are corresponding angles because they are the same side of this intersecting line and both are above the intersecting line. I mean parallel lines. Yeah. Let's move on. Let's look at some more interesting ones. So, let's see how many more seconds it takes to hear another my bad. So we have these two parallel lines.
Bro, it's not funny, bro. Stop laughing. It's not funny.
Okay, this is 80 degrees. We have been asked to find out this value. This one.
80 degrees.
Okay.
It's like against whenever. Actually, that's wrong because shouldn't that be at 90 because it's perpendicular?
I said you don't have to rely on my drawing skills.
Oh, no, it's gonna be 80.
I have given you exact value of it. Yes, Sanvita.
80 degrees.
Suhina.
80 degrees.
Anybody who got different from 80 degree? So today I learned a trick. See, again, I want to hear all of you. Certainly, but there are things that are obvious. You can figure it out. Shh, out of here, please.
Bro, why everybody laughing when I talk, bro?
So why you have to talk in the middle of the class? Is it a parliament house where everybody has to talk?
No fair.
Then, here, we know that these two are corresponding angles, so this is 80, this is 80, and this is opposite angles. That's it, simple. I learned a trick that how we can save some time. If I let everybody say 80 degree, 80 degree, 80 degree, it will take 2 minutes. I'll reverse the question. Okay, if I hear an answer from somebody and I know that's an obvious answer, I'll say, okay, who got anything different from that? Okay. My bad.
Bro, why are you laughing at me, bro? It's not even funny, bro. Stop laughing at everything I say, bro.
Okay, guys, here. I'm saying I'm not entertained. See, I did not respond to it because I knew that will not be productive. That's the reason, okay? I'm not trying to hurt anybody here. I'm just trying to avoid wasting of time. This is x degree, and this one is given as 149 degree. So you have to find out the value of x. Yep.
149.
This is 149. I want you guys to find out this one. Yeah. Yeah.
31.
Wait.
You have raised your hand. Now you're thinking what my answer could be. You have to get your answer first before you raise your hand. Yes, Sanvita. 31. Nihan. Vasundhara.
31.
Shannon's Lane.
31.
Okay. That's same.
That's not a 41.
Okay.
Yo, you put my foot, bro. Oh, traffic.
Okay.
Is that a 49?
Okay.
Why?
So, shh, everybody here. Everybody here. And guys, we have to stop that wastage of time, please. This is 149. This is a corresponding angle. 149. 149.
Okay, that was not.
That was him.
See, it took another 1 minute to get another 2. My bad.
That's not.
Hold it there. We have only a few more minutes to go. No, we have 20 more minutes to go. But now, everybody here. Ajit, you're unnecessarily wasting time with her, please. And we put all the blame on Arav, but you are equally involved in all those crimes. Okay, here, these two are corresponding angles, and these two together will make a straight angle, meaning 180 degrees. So this angle will be 180 minus 149, which you guys rightly found that is 31 degrees. Okay.
Wait, so.
Are you AI? Where there is an answer without a question?
No, I'm just asking that if 40, wait, is that 40?
Okay, stop it. That is a wastage. What is that you are talking about?
I was gonna ask you. I thought that was 49, but that.
149.
Oh, I thought
You raised your hand already 15 minutes ago, before the question was put on the board.
You thought it was
And now you are asking about it. Okay, guys, stop that. Now, so we dealt with certain things around relating angles with parallel lines and intersecting lines. Anybody has any questions? Milana, Suhina, Sami? No. Hold it there.
Can we just do one more problem?
No, we'll come to that. Everybody clear? I know you guys are missing the fun by not being in the class, but trust me, it's not funny. I see kids are unnecessarily trying to disturb, so I'm just holding on to it. Okay, let's move on to the next thing that we want to talk about. Everybody we talked about similarity of triangles. Do you guys remember what exactly is that? There are other kids also. Let me hear them out also. Okay, sit down. Do you guys remember about the concepts of similarity of triangles? Hands down. I'll come to you.
Okay. What are you doing?
Okay.
3 pages.
Adam, I'll not entertain that in the class. If you keep on repeating these mistakes, I'll have to do something about it. And you know that could get really bad. Okay. So we are talking about similarity of triangles. Yes, Sanvita, go ahead.
It's like when two triangles have the same shape, but like not necessarily the same size.
Or they have all same matching angles.
Yeah.
Yeah? Okay. Same thing? Everybody same thing? Now, hold it there. Now I will give you guys actually something to break your head with. Now I have two triangles, A, B, C and D, E, F. Okay? This is, guys, can you keep quiet and listen to what I'm saying or what I'm, see what I'm doing on the board? This is 60 degree and this is 40, 60 is 80. And this is
180.
This is 60 degree, this is 40 degree and this is 100 degree. Don't go by what I have drawn on the, how it looks like, okay? Don't go by that, go by the value. I have not asked a question yet. Can you hold it for 2 minutes? I keep saying you have to hold your horses. And your horses are highly untamed, wild. Hold them. Here, this is 40, this is 60, this is 100. This is 60, this is 40, this is 100. If this is 5 centimeters, this is 3 centimeters, this is 4.8 centimeters. This is 5, this is, let's say, this is
1.5.
you tell the question also. 3.6, okay? So this is 5, this is 4.8, this is 3, this is 3.6. I want you guys to find out the length of this side. This side and this side. Okay, use notebook and a pen. Okay, Advik, no, control it. I'm being super serious right now. You cannot take the luxury of disturbing the whole class. Not acceptable. You keep quiet. It hardly takes me 30 seconds to call daddy. I can stop the class right now and call daddy. Do what you're supposed to do in the class. So, there are two triangles, A, B, C, D, E, F. I'm not giving you guys any information. We have three angles as 40, 60 and 100. Here I have 40, 60 and 100. And we have sides as 5, 4.8 and 3. Here I have side 3.6. I'm asking you guys to find out the length of these two sides.
Wait, does it have to be like exact?
Do something, then we'll talk about it. Let's not talk in air.
I have to go early.
Yeah, that's okay. Yeah, that's fine. Can you guys see what is there in the question? Everybody got the question? I read this 5 times. You were paying attention somewhere else. That's why I have to repeat one more time.
Wait, you swapped.
You come here. You come here. Adam, can you mind your own business for God's sake? God is watching you right now.
You swapped the angles for D and F.
I don't care. I did that on purpose. So you can see the board better now? Yeah, use that. Do something. I'm not here for any discussion.
I have a question.
What question?
Wait, so are you trying to find line EF?
I said find this side and find this side. I have given you only one information. And the 3 angles. This is here. Brain, eyes, ears, then mouth. You are flipping it upside down. Imagine how your face will look. Using the mouth first. Okay. I know I'm sorry about cutting all those bad jokes. Sanita, tell me better. What did you find?
For D, for the line DF, I got 2.
Okay.
And then for EF, I got 3.2.
So which one is how much? It's one more time.
3.2 for E and F, and then 2 for D and F.
Okay. Okay. Let's see. And Sanvita, though you have finished it early, I have not checked whether this is right or not, but I have tweaked the question a little bit on purpose. So if you overlooked something, you might want to review what you have done once. Okay.
Okay.
Why
Yeah.
do the angles equal to 200?
Which angle is?
That's another question.
That's a good point. 40, 60 is 100.
And
This is
80.
80. Sorry, that was a good catch. So that's why you need to sit in the first row always. You're sitting in the last row and struggling with what the question is. So there was a mistake in the question itself. This is 40, this is 60, this is 80. This is 5, 4.8, this is 3. This is 6.8 and this is 40, 60, 80, and you have to find out these 2 sides. So Sanjita gave some answer. I'm not writing it there because otherwise I will get confused, everybody else will get confused as well. So summary of that is this triangle has all the 3 sides, 3 angles known. Here you have 3 angles known, only 1 side known. And you have to find out the other 2 sides. Yes, Lach.
I don't know how to do these types of problems.
That's good. That's a good news for me. I can teach something. What's happening, Sandy and Celine? Are you able to give it a try?
Yeah, I'm still doing it.
Okay. So here I means who? Both?
Yep.
Okay. Alright. How about Suhina? Doing it?
And thinking about it.
Thinking about it. How about Shaurya?
Oh, I'm still doing it.
Okay. Gayatri?
I'm still doing it.
Okay. Arihan? Vasundhara?
Confused.
Confused?
Yeah.
Wonderful. See how crooked your teacher could be.
Not bad.
Yes, Vasundhara. Yes, one second. I'll come to you.
For E and F, I got 2.16,
Okay.
and D and F, I got 3.45600.
Okay. All right. So yeah, Advik, you're saying something.
I'm still wait, let me finish it.
Okay. So some of you must be thinking. Yep. Yes, Sanvita.
Can I change my answer?
Of course. It's
For
your.
D and F, I got 2.16, and then for E and F, I got 3.46.
Okay. Yes, Advik.
So for D and F, I got 6. And then for E and F, I got 3.75.
Okay. So now, just because we have only 12 more minutes left. Yeah. You guys are, see, the bad things are more tempting actually, right? Once you start learning things, when you see that some kids are doing something which is not as serious, I'll also do it. And that's where you get tempted to stop making that sound, that's not needed. Okay, so what I did was I just zoomed in a little bit so that I can get a better view of it and you guys can all see a better view of it. Now here's the catch. In this question, if you see, I did something mischievously. These two triangles, I am saying that they are similar, but I did not put the angles in the same position. 40 and 60, I flipped them upside down, okay? So you are seeing a rotated or flipped triangle right now. So I flipped them. So that you can apply one of the most important concept of similar triangles. When you look at similar triangles, if here first of all let's see if they are similar or not. There is one angle 60, one angle 60 here, one angle 40, one angle 40 here, one angle 80, one angle 80 here. So there, for every angle there is a corresponding matching angle. No question, they are similar. Yep. Everybody with me so far? For every angle there is a corresponding angle, matching angle, so they are similar. Okay. Now, when they are similar, that means their sides will be in the same ratio or same proportion. Now let's go side by side. Here in this case, you will not go by 5 by 3.6 will be equal to this by this, will be equal to this by this. No. You have to go by the angle. Yeah? $20. Okay, so here you will not go by what you are seeing visually. You will go by the angles. So here now you found that this angle and this angle are matching. You will go by the corresponding angles. Okay, so side opposite to this angle 3. 3 over side opposite to this matching angle is this one. So side opposite to this will be this one. So let's say this is x and this is y.
I don't get it.
Why these triangles are similar? Because the angles are matching. So when you're looking at similar triangles, you'll not go by the look and feel of it. Math is more point blank.
No, I'm not confused about like when you did like the 40 is.
So look at, these are two matching angles. So when you're trying to find the ratio of the sides, you will look at the sides opposite to that, those angles. Here this 40 and this 40, these are two matching angles, right? So here this 3 by this x. You are looking at the angles, matching angles. Now will be equal to second pair of lines, which will be again next angle is 60. Side opposite to that is what? 4.8 divided by where 60? 60 is this one. This is y by y.
That's confusing.
No, this is the basic concept. So if you are looking at two similar triangles, the ratio of the sides you will find out based on the angles. Because angle is your base for deriving this is similar or not. If I keep rotating the triangle, that doesn't mean your ratio will change. As long as your angles are not tempered, you are still similar triangles. Okay. To avoid that confusion, it always goes by the matching angles and the side opposite to that. So these two are matching, side opposite to that. These two are matching, side opposite to that. These two are matching, side opposite to that. Will be equal to 5 over 3.6. Now if you have to find out the value of x, you will take these two combinations. When you have to find out the value of y, you will take these two combinations. Am I making sense to everybody, or I am getting you guys more confused? More confused?
Easy. What?
Why you have to raise your hand for saying yes?
Wait, so this is similar to proportional.
Yeah. What is this?
Like he.
Half of the time I spend in the bathroom. My voice doesn't reach all the way to the bathroom. So how do you understand it? Okay, let me repeat. Arihan, you have put a thumbs down. What does it mean to me? Confusing or not confusing?
That I do understand.
You do understand? Okay. Now here, again going back to the same concept. If you have two triangles, and they are similar, the concept of similarity says if you have two triangles similar to each other, their sides will be in the same proportion. Meaning side 1 by side 1 of this, side 2 by side 2 of this, side 3 by side 3 of this will be the same proportion. But, so you'll have to hear me a couple of times, you might have to watch the video also a couple of times, and then do it by yourself, okay? Pick up some examples. So I'm just repeating myself. So if I have two triangles similar, what is the basis for we calling them similar? What is the basis for we calling two triangles similar? Their angles are matching. Angles are matching. Angles are matching. Lach, is that okay?
Then don't we have to say same?
No. Matching, same. Angles are same. That's okay. I'm saying matching because if I say the angles are same, then you might assume that okay, all the three angles are same. I'm not saying that. These two triangles are similar. This triangle's one angle has a matching angle, second angle has a matching angle, third angle has a matching angle. That's why they are similar. Lach, is that okay so far? No?
Yes.
Now, when your angle was your criteria for calling out somebody similar or two triangles similar, that remains your base. Your sides will be the same proportion. That's what similarity says. But which side? You will determine the side based on the angles. So take the matching angle of these two triangles. Okay, now you take this side by this side. And the matching angle is this one and this one. Take the opposite side to that. Okay, these two are matching angles. The side opposite to that. That ratio will be in the same proportion. That's what it says. Is that making sense or no?
Mm-hmm.
So, and based on that, you can find out. If you go by the angle, don't go by the look and feel. That this side by this side, this side by this side. No. If somebody like me who has twisted the angle, the triangle or flipped the triangle, you would go wrong actually. So your criteria is always based on the angles. I know it might be sounding a little cryptic, but cryptic meaning complicated. Okay. Saurya, Gayatri, Suhina, Sanvita, is it making sense or I'm Vasundhara? Okay. Okay. How about Milona dropped off? Milona is back? No. Sammy? Huh? That is not funny, Tasvik. Why you have to keep on making sound unnecessarily? Are you trying to be disrespectful or you enjoy doing the nonsense? Why are you looking at him? He's not going to save you. I'm not going to save you either. But my point is, let's not waste time. So I know we just looked at similarity of triangle as a basic concept. And we looked at one problem. I know it might be sounding a little confusing to you guys. So we'll come back to this one because similarity of triangle, though it's a very easy concept, but it might get a little tricky if you are just going by the visual aspect of it. You have to always look at visual aspect as well as the mathematical way to relate things, okay? Because similarity is all about angles, and when you have two triangles similar, their sides will be in the same proportion. What all sides? That's what angle helps you with, and we'll double click on this and do a few more problems to be 100% sure about it in the next class. Does it sound okay or you guys are concerned right now? Everybody okay? So the only takeaway is when you have two similar triangles, their sides will be in the same proportion, and which side is what your angles will determine, and we'll practice few more to be more clear about application of this concept. Yep. With that being said, I'll let you guys go, enjoy the rest of your evening, and talk to you guys again in a few days.
Bye, sir.
Bye bye. Bye bye.
Sure.
Bye bye.